Hello everyone, my name is Ashley Goodnight and this is my Reading Week 3 video. Just like last week, the main physics idea was Newton's second law, which is given by the equation and definition below. The formula of Newton's second law is delta V divided by delta T equals F divided by M. In words, this translates to the change in velocity divided by the change in time is equal to the net force divided by the mass of this object. Building off our understanding of this fundamental principle is its application through calculus. The equation on this slide, derived by moving delta t and splitting delta v to the other side, works over longer periods of time, similar to integration in calculus. By repeating this circled portion of the code for small accumulations of delta t, the velocities can be more accurate over longer periods of time. Compounding these loops or repeated equations is a very good approximation of the definite integral of the expression. Another way we furthered our understanding of Newton's second law is through the concept of acceleration. We can begin manipulating Newton's second law given by this first equation. Next, we have to define acceleration, which is equal to the change in velocity over time. Applying this mathematical equivalence, we bring mass over to the other side and substitute in the second equation to get this final form. The concept I found most difficult and confusing was Newton's universal law of gravitation, which follows this equation. It took me a couple rewatches to fully grasp how to find the direction of the position vector r using a third origin or reference point. I also had a hard time understanding why little g works, but what really helped me was Khan Academy's lesson on Newton's universal law of gravitation, which lays out the definitions, equations, and even common misconceptions of everything. Again this week, the videos mentioned the momentum principle. As I briefly touched on in my video from last week, I am familiar with applying this concept to elastic and inelastic collisions between two objects in 3D space. However, I had never seen the momentum principle applied to a position versus time graph in order to create a mathematical model of the motion. The last topic covered in this week's lessons was charge. We learned that charge has its own physical dimension called coulombs, and charge can cause either attraction or repulsion of particles. We also learned that the equation on the right is called Coulomb's law. I am studying electrical engineering, so using Coulomb's law and understanding the intricacies of charge are both pertinent to my own area of study. With that, I am concluding my presentation. Thank you everyone for listening. I hope to see you all next week.